Software Engineering Radio, episode 22, listener feedback. Hi everybody, welcome to another episode of Software Engineering Radio. This is another listener feedback episode. So first of all, thanks to all of you for giving us feedback in general and also to the specific questions we've asked you to give us feedback to. It's really quite cool to get such positive feedback on the work we're doing, and it really motivates us to continue with the podcast. Specifically, we had been asking you to give us feedback with regards to our hands-on episode on model-driven software development, which was episode 16. So the question we raised was whether it makes sense to have a podcast where we expect you to take a look at source code as we speak. And your feedback was overwhelmingly positive in two respects. First of all, it was positive in the sense that you said that it's really great to have a hands-on podcast and that looking at the source code actually really helped, and that this kind of practice-oriented material is really useful. The other question we raised was whether it makes sense to listen to the podcast without actually looking at the source code, because you might be on the train or in the car. And also there, the feedback was overwhelmingly positive in the sense that yes, it makes sense to only listen to it. The source code is useful but not really necessary. So we'll certainly produce additional hands-on episodes in the future, although the next couple of episodes, because they've been in the pipeline for a while, aren't hands-on episodes. There were also some more specific suggestions on how to improve such hands-on episodes. One was that we could think about producing a video podcast and actually filming or screen capturing what we do on the screen. And yes, we could do that, but producing a video podcast is a whole nother ballgame, and we probably aren't going to do that in the near future. Our regular feedbacker, if this is a valid English word, Michael Hunger, again asked us two questions. One was that we said that our start and end states in our MDSD hands-on episode have no name. Therefore, we cannot have a constraint that all named objects must have a name. That's what he was asking. Why is that the case? And so the reason is as follows. Since we assume that there's one start and one stop state, there's no point in giving these start and stop states a name, although this is to some extent obviously an arbitrary decision. So only simple state will extend named. You can thus still have a check that checks all named elements, that they do have actually a name set. However, what you cannot have is a check that assumes that all states are actually named. So you'd have to type this to named or to simple state. The second question he asked is, why is the constraint check not included in the model? In my opinion, UML supports OCL in the models. Wouldn't it be a better place to keep the constraints directly attached to the meta model and therefore validating the model directly, or at least saying that this is a valid model or not? Or does the separation of the checks have any other benefits, for example, different check files for different use cases? First of all, it's essential that whenever you work with the models, you first check the constraints. Technically, it doesn't really matter whether the constraints are in the meta model, whatever that means, or not. For example, you can easily distribute the eCore file together with the constraint files. In earlier versions of open architecture, where we had the constraints directly inside the Java meta classes, and there was an operation check constraints that actually did the checks, and this operation contained the checks themselves. This was bad, since it was not possible to check different constraints at different times during the generator workflow, and that really resulted in significant problems in several projects. Of course, it would be nice to add the constraints directly in the meta modeling tool, but EMF doesn't provide very nice support for that. I would rather enter the constraints into a text file with a code completing and syntax highlighting editor than typing them into a tiny text box with no context support at all. So yes, it's essential that you have a correct set of constraints, but currently I don't see the tooling ready to have them in the meta model, i.e. directly in the eCore file. There was also some feedback from Horst, who asked basically two questions. One is, I recently tried to play with Open Architectureware 4.0, but was a bit confused by the documentation. As a beginner who doesn't know about OIW 3.0, I couldn't easily figure out whether I should use the classical or the new 4.0 approach. Perhaps I give it another try when following your episode and looking at the code. So my answer, the rule is quite easy. Although it might not be stated anywhere that clearly. If you need to use non-EMF UML tools, you have to use OIW Classic. As soon as you want to use EMF and related tools such as GMF, for example, you should use OIW with EMF. The other question from Horst was, how do you test your template code? Only by testing the generated code or also on the meta level, i.e. do you do test-driven development on the meta level? So typically, you'd only test your templates by testing the generated code. You'll build a reference model, test model, and test the results of the code generation using normal JUnit or whatever else unit. In some sense, however, we'll also test on the meta level because constraints are a kind of tests. If I have a model-to-model transformation, I explicitly test it independent from the rest of the workflow using JUnit or constraints. Another question from Horst was whether it's possible to use Open Architectureware only inside Eclipse or how well it can be integrated with AND or Maven. So it's quite easy. You can use it outside Eclipse easily. We provide an AND task, and also a Maven plugin is currently in the pipeline. Andre Gonzalez from Spain gave us feedback requesting certain topics, specifically on software development processes, XP, UP, Scrum, etc. And we have something in the pipeline. 1 or 2 episodes from now, we'll probably broadcast our processes episode part 1, and we'll have a number of additional episodes on process issues. He also suggested to get Geert Bevin onto our podcast. He is the author of the Rife Framework, which uses continuations. And as it happens, I actually was in contact with Geert with regards to this continuations topic, and he gave us some interesting information about continuations in Java and specifically in Rife. And he sent us an MP3 file, which I'll play now.
Hi guys, you talked about continuations and Java in your podcast about the future of enterprise Java. You raised many questions about the applicability of continuations and about the possibility of doing them in Java. Our project Rife has been mentioned in that context, and you were wondering about the state of continuations. So continuations are part of the Rife Framework, which is a web application framework to allow you to easily express complex flows, control flows in your web application natively in Java. The only thing that you have to do is to insert pause method calls where you want your flow to be interrupted, and your local state and program location will be automatically captured, and afterwards, at the next request, the execution will automatically resume where you left off. Now, I hear you think, how is this possible since Java doesn't support continuations natively? Well, when your classes are loaded, we automatically detect if these method calls are present and then modify the bytecode so that in parallel we can maintain a method call stack and a variable stack that will then be stored by a continuation manager when that pause method call executes. Each continuation has a unique ID, and that ID can then, for example, be passed as a query parameter, and once it arrives at the next request, the web framework is able to look up the continuation from that unique ID and obtain it from the continuation manager. At that point in time, the continuation will be cloned so that you keep 2 distinct versions of the continuations present. This allows the back button, for example, to work seamlessly because each individual continuation step will have a unique ID. Now, of course, to be able to do this, the cloning has to be possible, so all the variables on the stack have to be clonable. Rife implements a whole number of default behaviors with regards to cloning. So in most situations you don't have to do anything as a programmer, but sometimes you might have to implement the clonable interface properly if your classes are too complex. Another thing to consider, of course, is that if you have a very large local variable state, you might opt to not clone it and to have each continuation just use the same state. That is possible by setting a specific configuration flag. Now, another question that we frequently receive is if this continuation functionality is only possible within Rife. Actually, it isn't. We have started work to extract this functionality in a dedicated library, and it has as such already been picked up by, for example, WebWork. We are now continuing the effort of this separate continuations library, and within the next few weeks we suspect to be able to release a first stable version of this. Additionally, we're also working on a GSR proposal for continuations, so that it might be used in any kind of Java project, even not web-related. Thanks a lot for listening. I hope you learned something about continuations and Rife. You can find more information on rifus.org, and if you have any additional questions, feel free to hop onto the mailing list and ask them there.
So thanks, Geert, for clarifying that. And to all you other listeners, if you want to give us feedback and want to send us an MP3 that we can actually play in the podcast, you're invited to do so. So instead of sending us text, please send us an MP3 with at least 128-bit encoding, so we can repeat it or play it in decent quality.
Another feedback came from Bill Pugh, one of the key people who defined the Java memory model. He sent an email commenting on episode 19, which is the second concurrency episode, where we erroneously stated that the double-checked logging idiom was broken and that this was a Java-specific problem. This is not true. The problem is not Java-specific. It is common to all, basically to all languages. But it is obvious and it's more apparent in Java because Java has an explicit memory model. Other languages don't, but it does not work in C++, for example, with common compilers. Whereas in Java, in current Java versions, it is not broken anymore. The memory model was fixed. So what is at the heart of this weird thing of double-check locking being broken or not? Well, the underlying problem is a common optimization, namely the reordering of processor instructions as a performance optimization, as I said. It's very common. And while we're inside a single thread, it is often possible to change the execution order of instructions so that they're executed in a different order than that which is apparent in the source code, as long as the net result is not cannot be seen by other code. For example, if we construct a new object, call a constructor, and assign the newly constructed object to a variable, then it is necessary to first complete the constructor call, and only if the constructor is finished, we assign the fully initialized object to the variable. That is the specified behavior. But as long as we're inside a single thread of execution, it is perfectly okay to first allocate the memory, then partly initialize the object, then assign the memory the memory location, the pointer, to the variable, and then finish the initialization, that sort of thing. This sort of reordering is helpful to better fill the internal queues of modern processors. It's quite common. But this leads to problems in the context of multi-threading. As long as we're inside a single thread of execution, it does not matter because, there's no other code that could observe the partly initialized object through the variable, because the single thread, the next command, the next statement in this single thread of execution, does not get control until the assignment is finished. But if we have another thread, it is possible for the execution to be interrupted in the middle of the initialization of the object, and if due to instruction reordering the variable was assigned a partially initialized object, then the other thread can dereference this pointer, take a look at the partly initialized object, and this is bad. It's weird, leads to weird errors, and this is at the heart of why double-checked locking was broken. This sort of problem in the context of multi-threading is an old one. It's well known. Hence, the keyword volatile was introduced. Volatile is intended to sort of mean this variable should be accessible from several threads. The most important consequence of that is that all write accesses to such a variable go directly to memory. Other variables are sometimes cached in thread-specific memory or even processor registers, but a volatile variable must always be written right through to the heap memory, so that other threads immediately see the current state. A more subtle other aspect of volatile is that processor instruction reordering must be reduced to such a degree that other threads will see a consistent, view of a fully initialized object, sort of, which is a vague way of saying this, and this is a really complex thing. The Java memory model, the first version of the Java memory model, attempted to specify this, it specified which reorderings were permitted and which were not permitted for volatile variables, but there were some special cases that were not dealt with correctly in this memory model. And this is why double-check locking was broken. There was a Java specification request as part of the Java community process, JSR 133, which was finalized in 2004, which defined a new Java memory model. This is where Bill Pugh did a lot of the work. And this meant that in JDK 1.4 hotspot and JDK 1.5, which is now called J2SE 5, volatile ensures that actually only such reorderings of instructions are allowed that really allow give other threads a consistent view of the state of variables. So double-check locking works with J2SE 5 now. It's a little stricter, but it still permits some process instruction reorderings. Other languages, such as C++, for instance, which is the language where double-check locking originated, do not specify an explicit memory model, not as part of the language specification. This means that there is no way to verify or falsify that double-check locking or other idioms of this sort work or do not work with the language, because the language specification is too weak, too vague to allow this sort of proof or disproof. But actually, for C++, C++ multi-threading libraries usually just delegate this sort of thing, or some of the things, just through to the threading model of the operating system underneath them, and just do some reorderings. And actually, these reorderings often break things like double-check locking. So to summarize, we stand corrected in two issues. Firstly, double-check locking does work with current Java implementations, with the current Java virtual machine based on the new Java memory model, which is part of the current Java specification. And secondly, which is even more important, the problem that we mentioned is not a Java problem, but it's a language-independent problem, because this sort of processor instruction reordering is a common optimization of compilers independently of the language for which they compile. Java has an explicit memory model that allows us to verify or disprove that certain idioms work or do not work. Other languages do not have such a memory model, but that does not mean they do not have the problems. It just means that we cannot make any general, cannot say any general things about whether they have these problems or not.
Gregory gave us feedback and specifically asked us whether we're planning to discuss the topic of documenting the software development process and also of documentation in general. And something I have to say here is that we're planning on interviewing a guy called Andreas Rüping. He's the author of a book called Agile Documentation, which I personally really like. And this book is about how to write efficient documentation in projects, what should be documented, how much, for which target audience. And he also talks about how to write nice documents, things like layouting and stuff. So we'll have an interview with him on that topic upcoming. There was more feedback from Michael Hunger, and he specifically asked with regards to how to organize a model-driven software development project. In the MDSD episodes, I kind of suggested to have separate teams, one for developing the meta artifacts and other teams who would use those meta artifacts to develop actual applications. And in contrast, Eric Evans in his interview suggested that the team that builds the application should also be the people who build the language, because building the language helps understand the problem and therefore makes the team more productive. So I think the approach I suggested works really well if you have a number of similar applications, product lines, or in case where there's a complex technical infrastructure or architecture for which you want to simplify application development. Eric had another context. He wanted to use DSLs to enhance the expressive power of a domain language. Here, the language is used to help application developers to express their potentially complex algorithms. Here, of course, it is essential that those folks who use the language are also those who create it. They create the language to help themselves express their functionality. So I hope this clarifies the point. So, this basically concludes this short feedback episode. Again, we didn't read all the emails that said that, we're doing great work and this is a great podcast and we should go on. We really appreciate those emails. Keep them coming, but probably it's not very interesting for the listeners to hear all of them read out loud from the podcast. So thanks for your feedback, thanks for listening, and see you next time. This was another episode of Software Engineering Radio. The Software Engineering Radio team wants to thank Henning Pauli for providing the music, as well as Libsyn.com for hosting and bandwidth. For more information on the podcast, past episodes and feedback, go to se-radio.net.